not working. So Max should work always out of the box and I will try the VGA. I got an adapter for VGA. Okay.
Ale to. Redukce zachrání.
Do whatever you want. Just don't give a fuck. Sorry? Yeah. 5 minutes. So it's in 25, all the questions must be finished. So then okay. 5 minutes. So at 50, you just show me the 5 minutes. Yeah. Hi. Thank you all for being at my talk. It's great, so many people. Some of them I paid for them, but I don't know if this works. Yeah. So who am I? I'm Jorge Morales. I'm developer advocate for the OpenShift team. I come from Spain. That's why my weird accent. And this is the places where you can find my work. Okay. So application development is changing. It's been changing lately. So now we have been going through this shift from legacy to microservices thing, pain. So developers has been changing also how they package applications right now. So they've been packaging probably as zip files, star files, in VMs, deploying in VMs. Now they are starting to deploy applications in containers. And the application operational environments are also changing a lot. So we are seeing a move into the cloud, how we are starting to write our applications as developers. We need to think in a lot of things that as developers we usually didn't think about that much because that was more the operational types of things. And the development methodologies right now also changed. We are in a moment where DevOps is really important. We are getting a lot of, as a developers, a lot of visibility into what's an operational platform for writing our applications. How Red Hat or how we are supporting all of these changes that we are going through a lot of set of open source technologies, which in the middle of them it's Kubernetes, which is the most important one. Docker provided us the Docker container format for running applications in container, packaging our applications, and Kubernetes has given us the ability to run them at scale. And Red Hat has OpenShift for that. But the new developers, they are just not simple developers. That means that as developer, you need to understand and you need to focus on some other things. You need to understand how your application will be running because there will be some things that are now responsibility of the developers. If you think about what types of workloads you can have in OpenShift, there is a multiple types of workloads, how you will be able to deploy your application. We'll focus on replica sets, which is deploying your application as pets or as cattle. That means that they will be replaceable. That usually will bring you or will give you the possibility of having your application running and replacing it frequently. This type of workload usually gets described in OpenShift in a thing called deployment config. In Kubernetes, that's deployments, which provides some functionalities. And like the number of instances, the description of what the application will look like, the containers that will be describing your application. And one of the most important things is how you will be rolling over new versions of your application. If you think as an application developer that I want it to be, my applications, I want them to deploy frequently in this DevOps world where I will be making changes very constantly, and I want them to roll them out to production or to the users without them noticing, the strategy is a key thing you need to understand. So there is 3 different types of strategies that Kubernetes supports out of the box: recreate, rolling, and custom. So the recreate strategy, what we'll do is just tear down all your instances of the application and create a new or deploy new versions of your application. Of course, this type of strategy doesn't allow you for zero-downtime because you will be just tearing down whatever you have and bring it up. There will be some time where your application will not be live. Okay, so it doesn't allow you for zero-downtime. There is another strategy that is rolling deployment. That means that gradually we'll be introducing new versions of your new instances of the new version of your application, and will be, once that version is up and running, it will tear down the old version. So it will gradually move from one version of the application to the next one. Of course, there is a lot of additional capabilities, like giving you the power to roll back if there is an error and things like that. Does this strategy allow you to do zero downtime? Yes, it does. And there is also a different strategy that is custom, that is at the end is you will define how you will do that. So that depends. Depending on how you create that strategy, you will be able to achieve zero downtime of your application or not. But what's the problem now? The problem is that when a container starts in OpenShift, in Kubernetes, it's not really when your application starts. There is a time since the container is ready that your application may be still starting up. And the platform needs to understand that time difference between the container start and the application start. So for that, the rolling deployment strategy, as it will wait for the new pods, it needs to understand when really the application is up and functional to do that rolling deployment. For that, it uses 2 things. Health checks. Readiness, it tells the application when the application is ready to accept requests. So that means that if, for any reason, your application breaks, it will just take it out of service, but the application will be still live. And the liveness probe, it's a different type of check that the platform will do for you that will tell you when your application is healthy. So that means that the application, if it's not healthy, I will redeploy a new version of the application. In this cattle strategy, when you are using this raw replication controllers, if one of these checks fail, it will just deploy a new instance of your application. These checks can be made in 3 different ways. It can be an HTTP check, that it will just issue, the platform will do a query to your application, and if it gets a response code, HTTP response code between 200 and 399, it will be okay. Otherwise, it will be failed, so it will just act on as a failure. There is a container execution check. That means that the platform will just execute a command in your container. So you can provide a script or you can provide anything in your containers that the platform will query and will just give an answer if your application is healthy or is ready to accept requests. Because it's a script, it uses the 0 return code for success and anything else for failure. And there is the TCP socket checks. So that means that if I have a port 8080 listening, that means that maybe my application is ready. So here comes how it works. Readiness probe, there is a lot of configuration, but Readiness probe just says when my application is ready to accept requests. So if my application fails a certain amount of readiness checks that I configure, it will be taken out of service. Not really, it will not be redeployed, but it will just be taken out of service. When the readiness check then succeeds again, so the platform will be checking your application constantly. When it's when the check succeeds again, it will be taken again into service. So this is a graphical representation of load balanced services. You have like 3 instances of your application. If one of the checks to one of the instances fails, what it will happen is that there will be no request going to that instance. But the instance still will be live. Okay? The instance will be live. The platform will be querying for your application to be ready, and whenever it's ready, it will put it back into service. The liveness probes, on the other hand, what it will do is, if there is a failure on the liveness probe, what it will do is just trigger a new deployment of a new version. So it will just say, this application is not functional. I cannot recover, or it will not be able to recover from the problem. So I will just spin a new instance of that application. Okay. But there is a problem whenever you do kill off your instances, and it's that there is a time usually when you are using, for example, application servers, where you are using databases, that you need to release the resources that you are using in a safe way, so they can be reused, they can be properly terminated. So you need to also, whenever you create your application, take into account that there is one period of time between you get the signal of you are going to be terminated, so you will not keep accepting requests, and you will be able to start releasing your resources safely, and there will be one period of time that your application will be still live without request, so you can close all of that. This is something that you need to take into account. And of course, because these applications run in a container, you need to be able to propagate all the signals, the term signal that the platform sends to your container. You need to be able to terminate that signal. So you should use exec to propagate that signal to the start process. How this works, the same. Whenever you get a sick-turn signal, it will just take out the readiness check. After the period of the amount of readiness that you say it will be not ready, the server will start stopping the container, and after some time, it will kill it. If the server has not stopped gracefully, it will kill it. So with all of that, OpenShift deployments provide one additional functionality or capability, is that whenever you are doing this through the deployments, it will do this in a continuous way. Okay, so we will take all of that previous information into work. When there is a trigger for a redeployment, either because you want to release a new version, you want to redeploy a new version, or the platform wants to redeploy based on some changes that you have done, there will be a point in time that gets the redeployment process starts. The first thing that will happen is that you will start a new endpoint, a new instance of the new version of the application. That's the upper graph. Once that application is being started and the liveness checks will succeed, you will remove the endpoint of the old version. So there will be no new requests coming in. And eventually, the old version will get released. There is a period of time where you will wait until that version is released. So that means that you need to take into account all the timings involved in this process, and you need to take into account how you configure this as an application developer, so you can allow for being your application constantly up whenever you redeploy a new application. So this is usually the graph that, yeah?
Well, actually, endpoint means, for example, if I'm developing a web application,
yeah,
there is a short time where two endpoints are available.
So
I couldn't have two sockets reading from port 80.
No, there is different instances. So that means that once this instance gets up, the other instance gets down. So the moment you get a request, it will always go to, at this point in time, it will always go to the new instance. Of course, to the new instance which is up. Of course, all of the clients sockets that you already have open to the old instance will still be there, and you have time for your application to stop them gracefully. If you are in the middle of a transaction, you have time for that transaction to finish. Okay? And this is usually the graph that you'll see whenever you are doing a test, a continuous test, and a redeployment. At this point in time, you will see that a redeployment of a new version happened, and all the result codes from querying the application constantly are 200. Okay, so I will test this. I will show it through them. I start a local cluster.
You make your font bigger.
Yeah. Is this big enough? Okay, so I'm using OC cluster locally in my laptop, which I use a script to make it more developer friendly. So I have a cluster called DevConf. So I will start it up. Okay, so once the cluster is up, I have an application deployed, which is taking into account in the code everything how to release the application, and is creating all these probes, so the platform will be able to understand deploy, and I have 3 instances to show this. So the sample is a really simple example, but it makes the showing it really easily. So it just shows a hello world. So what I have is a sub UI as well, running somewhere with a load test. So I have a number of threads, 10 threads that will be querying. Constantly without delay, so this will be more frequent, and the strategy will be thread. Oh, simple. Burst. Okay, so I started, and as you see, as I started, for this test, I have some assertions to validate that what I'm doing is getting the output of the application. So if in a point in time any of the requests fail, doesn't get a 200 HTTP status, or doesn't get the hello world internally, will just show as an error. So I can now do a redeployment. Okay, so to do a redeployment, I can just redeploy the same application, the same version of the application, just for an example, or I could deploy a new version of the application. So I will just redeploy. I will do it from the console. Somehow the command changed in the last release. I haven't tested this. You go here, and we just deploy a new version, and we can see the pods. We will see that there is some pods creating, and as soon as we have one new running, there will be one terminating. There is one running and one terminating. Why? We will see some of them terminating and will keep terminating for a while, because this is the graceful shutdown. That means that I'm not killing the old application instantly. I'm leaving that for room to die gracefully and to release all the processes. So right now I have 3 instances running, and 2 of them have already terminated, and the third one will terminate soon. So if I go back to the sub UI, I should see that there was no errors in this column, which it's not big enough, but there is no errors. So I did an update of my application without any client noticing that I created the application or I changed the version of the application. So we achieved the zero downtime. What if there is persistence? So this really looks fine for microservices, for stateless services, but what if there is persistence? As a developer, what you need to take into account is that if you are modifying also something related to persistence, like a configuration file, data file, or a database, you need to try to design all of that to be backwards compatible. Not only to be backwards compatible, but you also need to take into account that your upgrades may be rolled back. Whenever you roll back your application, you may not be rolling back your database. So you need to take into account that changing into schemas need to be compatible. But what if those changes cannot be compatible? Or if you need to change also the database, the schema. So if it's compatible, you can use pre-deployment, which is something that comes with the deployment that will make the change into the database just before you update the application itself. You can use blue or green deployments, or you can use a pipeline orchestrated, where you include, for example, a job that will do the database update, and in the pipeline, if there is a rollback, you can also include a job to do the rollback of the database. If there is a change that is not backward compatible, of course, you will not be able to achieve in any way zero runtime. There will be some caveats, but this is not the topic of this talk. So will you be able to achieve zero runtime if you are changing the database? It depends, but probably, yeah. So remember, as a developer, you need to choose the appropriate strategy. Usually for development, it's very handy to have a recreate because you will use less resources and it will be faster. But whenever you want to have zero runtime, you always need to have a rolling update. You need to create health checks. So your application needs to have specific endpoints providing the liveness of your application and needs to have that available. Because otherwise, you will, every time you update your application, you will have failures to your customers, to your clients. You need to propagate the signals to the internal process to provide graceful shutdown. So you need to account into be able to release all the.
Do they source to image images that OpenShift provides already have the credits?
Yes.
In there?
Yes. So all the images that OpenShift provides, they have readiness checks, or they no. Maybe not the Python or...
Language one's better.
Okay, so the SCLs don't? The SCLs don't?
The S2I ones, the language is better.
Okay, the languages. So Wildfly, EAP, so the products, they do. They provide these tools. The languages not, because at the end, what you will be providing is your application, your specific application. It doesn't... how you check. But if you think about the checks, the HTTP and socket doesn't really need anything specific from your application. Of course, HTTP, what it needs is that you create an endpoint that provides that logic. If you go to the container execution, that means that you need a script in your image to provide that healthiness of your application. If there is data involved, try to make the updates backwards compatible. That means that usually if you break the schema or if you make something in SQL that is not compatible, you may be able to roll over, but the problem, you may not be able to roll back. So don't do that. Always keep in mind that rollover forward, it's as important as rolling backwards. So that means that test under load, the rollover as well as the rollback. The rollback is also very important for development. And automate everything if you want, if you can, through pipelines, the use of pipelines that the platform provides. These are the resources. These are the GitHub project is over there, and this is the script that we have created, my team has created to make a OC cluster app developer friendly. Okay, so you have any questions? No? Yes? Sorry? That depends on the application. So usually with WebSockets, what you will need is for your client side to reconnect on fail. So because WebSockets are persistence connections, so on updates that connection will break. So you will need to take into account to reconnect the application, which may be transparent depending on what's doing at the time, or maybe not. Yeah?
So if I was deploying a Word file or your file from PAT and doing a rolling update, would it start serving traffic automatically to the new containers as it reaches the liveliness probe or the readiness probe?
The liveness.
I assume liveliness is just when the container is running. Readiness is when the Word is deployed.
So in a redeployment, it will be the ready. So to get it into service is the readiness probe. The liveness probe will get also, both of them can be at the same time or can be different timings. Your endpoint will be hit when it's ready. So with the readiness probe, the endpoint will be added to the service endpoint load balancing. Usually, what I've seen is that most of the people, they use the same probe for readiness and for liveness.
And I just add that to the JSON or YAML?
Yeah. Yeah. Most of the templates that we provide, they have that out of the box. For EAP, for example, they have an internal script doing the checks using JBoss CLI to check. Okay. Yeah. Any more question? No? That was the last? Yeah. So that was the last. Thank you.
Did you copy the presentation to the USB?
No?
This
Do I
one.
have a USB?
That's for the
Yeah.
website.